Welcome back to my video tutorials, Chartered Financial Analyst Level 1. This time we'll be talking about deriving a demand curve. We'll be dealing with the effects on the quantity demanded if the price goes up or if the price goes down, and considering the own price. So if a good's own price goes up, where does the quantity demanded go? Does it go down? Does it go up? And the result will be dependent on this. Taking a look here, the mind map, like for a normal good, it is this way. Price going up, quantity demand goes down. But with a Giffen good, it's totally contradictory to this, meaning that the price goes up and so does the quantity demanded. Or if the price goes down, the quantity demanded goes down just as well, which is not normal, which is totally not normal at all. So this is not a normal good, this would be a Giffen good. Now, deriving a demand curve, we'll be doing this for a normal good now. And the normal good means that with the decreasing price, there's something doing with the substitution effect and the income effect. This video, we won't consider so much substitution effect and income effect. That will be done in a different video, but here now we will consider the derivation of the demand curve. And let's do that. Let's do that real quick. Now, first of all, there is the budget constraint. There's the budget constraint here, and those 2 points. Those 2 points are given by the income divided by the price of the first good, P1. And this second point here is the income divided by the price of the second good. So divided by the first good, by the price of the first good, as well as income divided by the price of the second good. Now that's the budget constraint. So the budget constraint tells us, for example, this point here, let's call it A, is feasible because our budget is sufficient to pay this amount of Q1 and this amount of Q2. Whereas with this point, for example, let's call it B, this point is not feasible. This point is not feasible because we cannot afford it. We cannot afford this amount of the first good, Q1, and this amount of the second good, Q2, because our amount of money that we actually own is not sufficient. It's not large enough, it's not high enough to afford this amount of two goods, Q1, Q2. That's it. It's like if we try to remember again what was the meaning of the budget constraint. Now, we want to derive the optimal points. The optimal point, for example, that is, what a nice curve, what a nice line. That's the so-called indifference curve, and that's the one indifference curve where the budget constraint is tangent 2. Where the budget constraint is tangent 2, what was the meaning of an indifference curve? U0, for example. The meaning is very, it is easy. It is easy to remember because the indifference curve is the location of the different possibilities of quantities of two goods where the utility is the same. So the utility is the same on this line. And to U0, the tangent line, or the budget constraint, is tangent in point, let's call it G1. Let's call it G1, which means that given the price goes down, but we'll see this only later. We'll see this in 30 seconds approximately. So with, first of all, this is the first situation. So the quantity is this. That's the optimal quantity, optimal for the two goods, of course. but especially with regard to the first good, Q1. Q1 star, because a star always denotes the optimal situations. So here, that's the first optimal situation, optimal especially with regard to the first good, meaning that this is the first point, I don't know, C for example. Let's call it C. Now there's something changing. There's something changing and the price needs to go down. The price of the first good, I mean, it doesn't have to go down, but if it goes down, what happens? This point here does not change at all. Does not change at all. Actually, no, it changes, but I wanted to say something different. The budget constraint shifts. It shifts around this point, which does not change, and it goes to this direction, So looking at this point, the income divided by P1, the denominator goes down and the fraction as a result goes up. Because if the numerator doesn't change at all and the denominator goes down, so the fraction of course goes up, right? Which means that we have a second budget constraint, which is this one, which is the next one. So it twists, meaning that if there is a bunch of indifference curves like that one, that's the second indifference curve, denoted U1 for example, there is a new tangent combination, there is a new combination for a price that's inferior. So the price went down for the first good, which means P11 is inferior, strictly inferior to the first price that we had, P10, meaning again that the new situation can be seen here. The new situation can be seen here, which is D. And so, as a result, if we do this again and again and again, if we further let the price go down so the budget constraint is going to shift again a bit to the right and leading again to a point, to a new optimal point that is a combination of a price that went down and a quantity that went up. So all in all, this, if it's a straight line or not, let there be no question. It can change. Like it can change. It could be a straight line. It doesn't have to be a straight line. But now that's the demand curve, and that was the derivation of the demand curve. Demand curve. Isn't that a very nice line, the demand curve, which could be derived by just the change of the price, and very important, by the change of the own price. So not the other price, not the price of the second good, because that would deal with cross price elasticity, but we have to deal with the own price elasticity. So again, the own price elasticity was in fact negative, which led us to the normal good, which was the indication of the normal good, and the answer was a negatively sloped demand curve. That's it for now. Thanks for watching. I'm Daniel Lambert, Berlin.